Alright guys, today we are going to be working on our 10.2 notes, which will go over triangle congruence proofs. Looking at this table given to us, we have some diagrams that are provided, we got some statements, and then we have reasons. So I went ahead and already divided mine up just to make it a little more clear to see what I'm looking at. And I kind of already started the first problem. Anytime you're given a statement, it's an if-then statement. If something happens, then here's the result. So our statements go in this column, and then our reasons are in this column. For the first one, our if statement was saying if point B is the midpoint of AC, then side AB is congruent to side BC. We know that if we have a midpoint, then these two sides are congruent to each other. Whatever came after if, which I highlighted in yellow, went in this first box. Our implied statement, so whatever happened afterwards, which was these sides are congruent, went into the second box. Anything that comes after our if will be our given. And the reason that this occurred was because, hey, we had a midpoint, it was in the middle, therefore I have these two sides that are equal to each other. So we're going to practice that with the rest of the statements that were provided. If it helps, go ahead and circle your if and your then. I'm going to highlight whatever came after if in yellow, and I know that has to go into this first box. If CD is a bisector of AB. You might have to write a little small. So CD is a bisector of AB, then what happened? AE is congruent to EB. Okay, this was our implied statement. Remember, whatever comes after if, this was provided to us. I see it, it's there. Therefore, my reason for it was given. Why is AE congruent to EB? Well, I had something cutting it. We call that a segment bisector. So our definition of the segment bisector would be our reason. Okay, this next one, there's more blanks. So we're going to have to fill all of them out. Plus, I noticed this, if I circle my if and my then, they did not give me my implied statement here. I got to write it down. So let's look at what they gave me. They're giving me if ray DG is a bisector of angle CDF. Let's go ahead and write that down. Ray DG is a bisector of angle CDF. I know this was given to me. Then what happens? Here's my ray. It's cutting through this big angle, CDF. And notice it creates two different angles now, angle 1 and angle 2. I know that anything that acts as a bisector will give me two equal parts. And in this case, I got two equal angles. So we're going to write, then angle 1 is congruent to angle 2. Rewrite that down in this box. Why is this occurring? We're going to say because of the definition of an angle bisector. Definition of angle bisector. And I'm going to abbreviate here just because we are writing a lot. Okay, this next one, I would pause the video, try it out on your own. Alright, hopefully you pause the video. You should have circled your if and then statements just to make things a little clear. Alright, this was given to me. Side AB, and don't forget that upside down T means perpendicular. So AB is perpendicular to CD. Then what happens? Angle 1, angle 2, 3, and 4 are right angles. Angle 1, angle 2, angle 3, and 4 are right angles. You should have written given. This was provided to me. Why are angle 1, 2, 3, and 4 right angles? Well, if all of these are right angles, our reason is all right angles are congruent. Right? If this is 90, this is 90, this is 90, this is 90, those are all the same. All right, so that's our first part for today's notes. Moving on, we're going to be looking at parallel lines. Okay, so it tells me here A is parallel to B. These are my parallel lines. And then I have a transversal C cutting through those. So I have 8 different angles here. First thing is stating, go ahead and find all of our vertical angle pairs. Remember, vertical angles are angles that are across from each other. This is congruent to this angle. This smaller angle is congruent to that angle. So what would be congruent to 1? Well, 3. They're right across from each other. So we're going to write angle 1 is congruent to angle 3. 4 is congruent to 2. They're right across. Angle 4 congruent to angle 2. And then you keep going. This is my other section here. I got angle 5 congruent to angle 7. Angle 8 congruent to angle 6. Those are all my pairs. Corresponding. We learned this word back in semester 1. You probably have already forgotten it, and that's okay. Reminder, this just means my angles are in the same spot, same location. So angle 1 in this section is in the top. What is in the same spot as 1? 5. They're also in the top, so angle 1 is congruent to angle 5. What would be in the same spot as 4? Well, 8. They're both on the left. So we're going to write angle 4 congruent to angle 8. Try to see if you can fill out the rest. So if you want to, pause the video. All right, hopefully you pause the video. Let's keep going with the rest. We got angle 2. I'm going to put my commas here. So angle 2 should be the same as angle 6. Congruent, and then angle 3 is congruent to angle 7. So I got all my 4 angle pairs here. And then the last one is talking about alternate interior. If you have me, I taught you guys to always shade the inside or what's in between our parallel lines. We call the shaded region our interior. Alternate means opposite. What is opposite of 3? 5. So angle 3 is congruent to angle 5. And they're both inside of the parallel lines. 2 and 8, those are alternate interior. And that's about it for here. Okay, moving on. A new word we're learning today, or a new term, when you're proving parts are congruent, after you've already proved 2 triangles are congruent, we use this thing called CP-CTC. That just means corresponding parts of congruent triangles are congruent. So we're going to be looking at that in one of our proofs for our practice. Let's move on to the next page. I just dropped my highlighter. Let me grab another one. Okay, let's look at example 1. So in example 1, we are given a statement here. I'm going to highlight it in yellow. And one thing I want you to know, when you're working with table proofs, your given statement will always go in that first box, which in this case, they've already written it down for you. Paste and copy. That's all we did. Why are these things occurring? Because it was given to me. So go ahead and write given. Notice they also provided a word bank for you. In this case, we're only using 3 terms. We've already used up given. Another thing I want you to do is notice in the diagram they did not mark anything at all for us. So we're going to actually go back and mark what these sides mean. So for the first one, it says AD is congruent to AB. I need to go back here and give it tick marks. AD is congruent to AB. DC is congruent to BC. I used up 1 tick mark here. I got to use 2 after the 1. Next one is talking about a side. AC is congruent to AC. If you're in my class, I talked about, hey, when you look at yourself in a mirror, you're looking at your reflection. AC is the same thing as AC because it's like a reflection, reflexive property. Hopefully that kind of helps you out there. Used up that. I gave it 3 tick marks. Hey, I got a side, a side, a side. I know that this is going to be congruent to this triangle. So triangle ADC is congruent to ABC because of our side, side, side congruence. Now, if you didn't have a word bank, go back and mark up your S's, your A's, whatever was provided for you. All right, that was a pretty easy proof. Let's look at example 2. Let me fix my camera real quick. Example 2, let's see. I am going to highlight what was given. Notice they already wrote it down for us. One thing I didn't write down for example 1 is that your proof, what you're proving, will always go in that last box. Okay? All right, so it says AC bisects. Okay, we got something that's bisecting an angle DAB. D to A to B is being bisected. I need to give this arc marks. And angle 1 is congruent to angle 2. This was given to me. The next one is angle DAC is congruent to BAC. I already marked that up, and we know they're congruent because of a bisect. Definition of a bisect. Next one, AC is congruent to AC. Oh, they're the same thing and their sides. I'm going to give it a tick mark. That is reflexive property. I'm starting to abbreviate here. And our last one, why are these triangles congruent to each other? Again, if you did not have a word bank, go back and label your A's, your sides. Hey, this is an angle, this is a side, this is an angle. It spells out ASA or ASA, however you want to say it, ASA. All right, let's move on, guys. We got 3 more proofs to get through. I know these notes are a little bit longer. Okay, example 3. This was given to me. I see it. This was my proof. They already wrote it down on the last box. But in this case, I noticed they didn't give me one of the statements, so I'm going to have to figure that out. Let's see what I need to mark up. IF, side IF, is perpendicular to HG. Perpendicular. What does that mean? That means that I have right angles. Angle 3 is a right angle, and angle 4 is a right angle. IH is congruent to IG. So I'm going to go back and give it check marks. My first reason should always be given. Okay. Why are angle 3 and angle 4 right angles? Well, what happened? Definition of a perpendicular, right? We have perpendicular lines. We know those create right angles. Here's my option, so I'm writing it down. And then make sure you cross it out so that you don't use it again. It says triangle HFI and triangle GFI are right triangles. We know both of these are right triangles because definition of a right triangle. All right, now we can move on to the next thing. All right, I know that I have a right triangle. Notice this is my hypotenuse. So I need to start thinking maybe one of the legs is congruent as well. IF is being shared by both triangles, and I know that IF is the same as IF, and it's provided for me. That is going to be my next statement. IF is congruent to itself, therefore, my reason is because of reflexive property. Now I can finally state, ooh, I forgot to give it the tick marks. This was a leg I got HL congruence, and we are done with this proof. Okay, example 4. Example 4 has no word bank whatsoever, but always try to start with the easiest things to fill out. I know my given has to go in the first box, and I know that my proof will go in the last box, so we're going to go ahead and fill those out. Okay, my given here was ML is congruent to OP, and NL is congruent to NP. Oh, they gave me a lot of information here. And NN and N is the midpoint of MO. Okay, this was given to me. Let's go ahead and mark up what we, or whatever they didn't mark up for us. In this case, I'm looking at it, I'm like, oh, they already did. They gave me those tick marks. The only thing they didn't do was, hey, look at the second thing they said. And N, this is the midpoint. I know midpoints create equal segments. Therefore, I know that MN is the same as NON. Did they say that here? No, they didn't. Hey, that could go in my next statement. MN is congruent to NO. Why is that? Definition of midpoint. We talked about that at the beginning when we filled out that table. Okay, moving on. What's the last box? Well, hey, notice we got our 3 things. This is a side, this is a side, and this is a side. Okay? I know this is side, side, side congruence. What goes in this last box? It'll be our proof, so I need to rewrite it. And make sure you rewrite it exactly like it was stated. Triangle LMN is congruent to triangle PON because of side, side, side congruence. Alright guys, we are almost done. We got one more proof, and then you guys can start on your practice. Alright, last proof. Probably the hardest one. This was given to me. Need to write given in my first box. Ooh, this one's kind of nice. They gave me a word bank. But they did not mark up anything, so I'm going to go ahead and mark it up. Angle A and angle D are right triangles, or right angles. I'm going to go and give it boxes. And it says AD is acting as a bisector, and it's cutting this line in half. So that means BC is congruent to CE. Okay, next one. Angle A is congruent to angle D. Okay, angle A is congruent to angle D. They're both right angles. What talks about right angles? All right angles are congruent. All right angles are congruent. I'm abbreviating a lot. I'm sorry. Okay, BC is congruent to EC. Well, why do we know this? Because AD acted as a bisector. We're going to write definition of a bisect. Okay, 3 more. ACB is congruent to DCE. All right, ACB, I am talking about this angle right here, is congruent to DCE. Ooh, wait. Yeah, DCE. Okay, I'm good. I started reading things weird. Why do we know this? Because remember, any angles that are across from each other, we call those vertical. Let's write that down on this box. Vertical angles are always congruent. Remember, our proof, in this case, I didn't even talk about it. We're not even proving that the triangles are congruent. We're trying to prove that this side is congruent to that side. We're trying to prove that. You got to prove that the triangles are the same, that they're congruent first. So what do we have so far? I have an angle, and a side. I see that there. Now that I've proven these triangles are congruent, now I can say AB is congruent to DE because corresponding parts of congruent triangles are congruent. CPCTC. This is that special one, okay? All right, guys, that is all for the notes. I know they were kind of long. Go ahead and start your practice. Practice will start on page 9. You got, I believe, 8 questions to go through. And if you have any questions, make sure you come to tutoring, and I will see you guys later. Bye.